next we will see some example here. So here we have considered a specimen like this, which is having a 25 mm diameter and its length is 200 mm. Okay, and this is subjected to tension test. In the tension test, the change in length observed is 0.05 mm for the applied load of 50 kilonewton. Okay, and then in the torsion test, it is observed that the angle of twist is 0.025 in terms of radians for a length of 200 mm. The specimen length is 200 mm. So, and here it is also observed that the torque or the torsional moment, okay, equal to 6 kilonewton meter. And what we need to find out? We need to find out all elastic constants. So how to find out these elastic constants? To find out other elastic constant, at least we need to know 2 elastic constant. Then only we can find out the remaining elastic constant. Okay. So but here the hint is given. From the tension test we can calculate Young's modulus. From the tension test we can calculate Young's modulus, and then from the torsion test we can calculate the rigidity modulus. So by calculating N and E, we can calculate the remaining mu and K by using the relations that we have already derived. Okay. So in that tension test, what is given? Delta L is given. Then I can calculate E. Okay. First of all, what is the formula for the Young's modulus? E equal to sigma divided by E. Okay. And what is the E here? That is the strain equal to delta L divided by L. And what is the delta L here? 0.05 divided by 200. Okay, everything is in the mm, so no need to worry here. So what is the value? So it's otherwise directly I will substitute. Why to do separately? Then here if I substitute directly, then what is the value of sigma? Sigma is F by A. Okay, in the tension test we applied force F equal to like this, and that is a 50 kilonewton. And if I substitute that, okay, first I will write the formula F by A into delta L L here. So F is 50 into 10 power 3, because that is a kilonewton. F is in the Newton, and L is, I am substituting L in mm. Why? Because delta L also mm. Delta L is how much it is given? 0.05. Okay. Before that I will write the area. Area is pi by 4 into d square. What is the d here? 25. Okay. 25 I will keep in terms of mm only. 25 square into 0.05. Okay, if I keep in terms of mm, then whatever we get, that value is nothing but megapascal. Otherwise you can write directly in terms of meters if you don't want to get confused in the future. So 10 power minus 6. Okay, why? Because here 1 mm equal to 10 power minus 3 meters, and here we have a square, so it will become 10 power minus 6. And after simplification it will become 407.44 gigapascal. Okay, mega is 10 power 6, giga is 10 power 9. Okay, and we found out the E value, and from the torsion test we can find out the N value. So we have the relation N theta by L equal to torque divided by J. Okay, J is the polar moment of inertia. Why we have used this relation? Because theta is given and L also known, and torque is given, and J we can calculate from the diagram. So here let's calculate the J. J is about this axis, and this axis is perpendicular to this cross section, and when the axis is perpendicular to the cross section, and what is the moment of inertia? So moment of inertia in that case is pi by 32 into 25 into 10 power minus 3 whole power 4. Okay, this is the formula for that. And after simplification what is the value of that? Okay, its value is 3.0679 into 10 power minus 7 meter power 4. Okay, either you can write individually or directly you can substitute in this formula also. Sometimes if it is a very big, then it's better to write individually than substituting in the formula. And here n equal to TL divided by J into theta, and T is the how much? 6 into 10 power 3. L is we are converting everything in terms of meter. Okay, this is 10 power minus 3. We need to multiply with 10 power minus 3, and here 3.0679 into 10 power minus 7 into theta. Okay, theta is already given in terms of radians. See, it is already given in terms of radians, so we are simply directly substituting it. See, instead of giving the radians, if the theta is mentioned like if theta is mentioned something like a 4 degree, then how to substitute this? So when you are substituting in the equation, we need to convert it into the radians, degree into radians. How we convert a degree into radians? That is by multiplying pi divided by 180. Okay, pi divided by 180. What is the meaning of this? See there, for 180 degrees, what is the value in terms of the radians? For 180 degrees, what is the radians? That is the pi radians. Okay, then for 4 degrees, what is the value? Okay, it is in the proportion. So let's say this is the x, then x by pi equal to 4 by 180, and if you take this pi that side, then it will become x. This implies x equal to 4 into pi by 180. Okay, so that is why always we say that whenever you want to convert degrees into the radians, we multiply with the pi by 180 degrees. Okay, and if you want to convert the radian into degree, then you reverse it, reverse it. Then in that case you multiply by 180 divided by pi, then the radian will be converted into the degree. Okay, these type of things we need to observe, because even though you know the procedure, and even if you think that you substituted everything correct, but you end up in the wrong answer, that is because of these type of tricky things. Okay, whenever you are substituting your angles directly into the calculation, then you always convert into radians. Okay, then what is its value after simplification? It is a 156. It is a 156.4458 megapascal. Okay, so we know n and we know E also. So from these two we can calculate remaining elastic constants. So what are the remaining elastic constants? So first one is a Poisson's ratio. So what is the relation between this Poisson's ratio? We know different relations. Okay, so this is the E. Okay, so relation which is involving the E and N and then mu, that is what I am interested in. So that we already know E and N, and from that equation we can find out the mu. So that is the idea. So from this you can find out mu equal to E by 2n minus 1, and if I substitute the values, then what is the value of E? 407.44 into 10 power 3, because this is a gigapascal and this is a 2 into 156.458. this is only megapascal, this is only 10 power 6, and giga means 10 power 9. Okay, minus 1, and its value is something like 0.302. so we got mu equal to this much. And if you know the mu, then how to find out the bulk modulus? Again, we can use the relation which involves the bulk modulus, Young's modulus, and Poisson's ratio. Okay, what is that relation? That is E equal to 3k into 1 minus 2 mu. Okay, so K equal to E by 3 into 1 minus 2 mu. So if I substitute directly, then it is 407.44. This is in the gigapascal divided by 3 into 1 minus 2 into 0.302. Okay, after simplification, its value is 342.963 megapascal. Okay, it became megapascal. Okay, so this is the way we need to find out. So next problem is, we have a steel shaft which is transmitting 140 kilowatts of power. Okay, units, you remember the units. Okay, power is a kilowatt and energy is a kilojoule. Okay, joule per second is the watt, and what is the power? The rate of work, the rate of energy is the power. Okay, what is the meaning of that? See, if the motor is running the shaft, that means it is doing some work in running the shaft. Okay, and how can you measure this work performed by the motor? Okay, you need to take a time span. Within the time span only we can measure. Okay, this much within 1 hour, how much work it is performing, motor how much work it is performing. That is how we need to measure. And when you are measuring the work done within a time, then it is called as the power. Okay, that is why it is a kilowatt. And this is running at a speed of 180 rpm. Again, see, whenever rpm is given, then how to convert rpm into radian and radian into rpm? Radian per second. Okay, so that is omega equal to 2 pi n divided by 60. Okay, this is in rpm and this is in the radian per second. Okay, by using this relation we will convert it. You remember this also. And what is the other formula that we learned previously? That is a power. So power equal to torque into omega. Okay, so if omega, which is in the radian per second, is not given in the question, so don't get confused. Okay, we can utilize this formula and substitute capital N so that we will get the omega. Okay, so and diameter also given, that is a 100 mm. And the first one is we need to find out the torque on the shaft, how much torque is acting on the shaft, and then the maximum shear stress, of course, and then the twisting in the shaft for a length of 6 meter length. Okay, we'll start with the torque. So what is the formula? So the formula is this one. We have the power is given. See, based on the given quantities, we need to change the formula. If the stress and related, the distance from the center is given, then we would have used the original formula. Okay, what is that? That is the shear stress. Shear stress by y equal to m by j equal to n theta by l. We would have used this. Okay, but instead of that, they have given power and then omega, so that we could use this formula to find out the torque. Okay, so what is the torque here? Torque equal to P by omega. What is the P? P is 140 into 10 power 3 and omega is 2 into pi into n, that is 180 divided by 60. So whenever I divide this thing with the 60, then you please remember that this should be written in the rpm. What is the meaning of rpm? The shaft is rotating or revolving in a minute. How many revolutions is making in a minute? That is the revolutions per minute. Okay, so what is the meaning of here? Meaning of this, the shaft is making 180 revolution in a minute. Okay, in a 60 seconds it is making a 180 revolution. That means in each second how much it is making? It is making 3 revolutions. Okay, each second it is making 3 revolutions, so it is very, very fast. So that is how we need to convert, and after simplifying that, then how much value we will get? What is the value? This is a 7.43 kilo Newton meter. Okay, kilo Newton meter. We found out the torque. Now we need to find out the maximum shear stress, and for the finding out the maximum shear stress we will make use of this formula. and whenever I say maximum shear stress, the shear stress is maximum at the circumference. So that means this is the y is the max here, and what is the y max? That is nothing but a radius in case of a circular bar. So tau max equal to in torque. This is a m is nothing but a mt or torque divided torque into y max divided by j. Okay, so if I substitute this, then what is this is a t into d by 2. Y max is r, which can be written as d by 2, and what is the j? J is pi by 32. For a circular section, the polar moment of inertia is pi by 32 into d power 4. Okay, then it will become d 16t divided by pi into d cube. Okay, so if I substitute the values, what is the value of t here? T we have derived from here, that is a 7.43 into 10 cube into 16 divided by pi into what is the diameter? Diameter is 100 into 10 power minus 3 whole cube. Okay, and after simplification, its value is 37.84 megapascal. Okay, this is the value tau max, and now we need to find out the twist angle. So we use either relation between this and this or relation between this and this. Okay, so it's better we will use the relation between this and this. Okay, then so n theta, here the theta can be written as theta can be written as L into L is how much? 6 meters. L into tau or this is called as the shear stress. Shear stress how much we got? 37.84 into 10 power 6. Okay, L into tau divided by n into y max. What is the value of n? N is 8 into 10 power 5 into megapascal. Mega means 10 power 6 into y max. Y max is r. R is d by 2. That is 50 mm. And if I convert into meters, then 50 into 10 power minus 3. Okay, so if I simplify this, then I will get the value 0.0056 radians. Okay, this is in terms of radians. So this is how we need to find out.
For engineering services general studies video lectures, visit www.iesgeneralstudies.com. For mechanical engineering video lectures and question and answer discussion, visit www.getnet.com.